Hello everybody, today we are going through the partial derivatives of a multivariable function. Consider that you have a multivariable function f in x and y, so you can find partial f partial x that can be written as fx, which means that you can find the derivative of the function with respect to x only, and you have to consider y as a constant. Otherwise you can find partial f partial y, which can be written as fy. So here you have to consider your variable is y and x is a constant. For example, here we have some rules. You have to consider these rules for the first derivative and second derivatives. All of them are second derivative actually. For example, if you have this function omega equals x squared minus xy plus y squared plus 2yz plus 2z squared plus z. If you wanted to find partial omega partial x, so you have to consider x, you have to consider the differentiation with respect to x, and y and z are constant. So the derivative of x squared here is 2x, as you can see here, and derivative of xy, derivative of x here is 1, so we have minus 1 times y, which is minus y here, and all of the other terms are constants because they don't include x, so they are constants, and we know that the derivative of a constant equals 0. Another example, if you have a function f of x and y here, we need to find fx, which means partial f partial x, and fy, which means partial f partial y. For the first one, partial f partial x, so x is the variable and y is a constant. The derivative of x squared here, put the power down, so you have 2 times 3, which is 6, and subtract 1 from the power, so we have x, and y here is a constant, so you have to write it as a coefficient of 6x. Here the derivative of x is 1, and y, you can write it copy paste as it is, so this is fx, or partial f partial x. Partial f partial y, you have to consider that y is the main variable and x is a constant, so derivative of y here is 1, so you have to write 3x squared, because we consider x as a number here, as a constant, so you have to treat it as a number like this 3. Plus xy, derivative of y here is 1, so you have to copy paste x, and this is your final answer of fy. If you have fxy equal this function, it is needed to find partial f partial x and partial f partial y. For partial f partial x, x is the main variable and y is a constant. So here the exponential e to the power xy, e to the power xy, its derivative is e to the power xy, and the derivative is with respect to x, so you have to follow the chain rule here, times the derivative e power xy times the derivative of the power with respect to y, derivative of y here with respect to x, sorry, derivative of x here is 1, so you have to write the derivative of the power with respect to x, which is y, because y here is a constant, we have to treat it as a number. Y ln x, derivative of ln x is 1 over x, and y is a constant here, and you can simplify your problem to be y e to the power xy plus y over x. For the second one, we wanted to find the derivative here with respect to y, so x is a constant. The derivative of e to the power xy is e to the power xy times the derivative of the power with respect to y, and derivative of y is 1, so you have to write x. Here derivative of y is 1 and ln x is a constant, and this is your final answer. Another example.